This is the most important part for my new computer case, which is going to be a small form factor design with a very unconventional cooling system. Routing a water loop has always been a challenge with a case this size, so I'm leveraging my workshop's newest tools and trying something unique. Recently, I've been doing a lot of work with water distribution plates. It all started with this front panel for my wall-mounted PC. I came up with the design, but I had to send it out to a local shop in order to get it made. I wasn't a fan of how long that took, so I ended up creating a new method for making these using the tools I already have available in my workshop. Now I'm ready to apply this new technique, and I wanted to pick something that would be a bit of a challenge. So let's go with a small form factor case design. Most people would consider that to be any case with a volume of 20 liters or less, and this one is going to be about 13. I'll start with a 3D printed frame that will hold a mini ITX motherboard, a full-size GPU, an SFX power supply, and a case fan here in the bottom. The other sides of the case will be enclosed with 4 distribution plates, containing the bulk of our cooling loop. Inside, we'll have the minimal amount of tubing necessary to connect our plates to the GPU and CPU cooling blocks. We're also going to need a radiator to get rid of the heat that this loop is absorbing, and here I'm going to cheat a little bit. I'm going to handle this with a separate unit that'll be connected to the case via quick disconnects and flexible tubing. One of the main benefits of water cooling is the ability to move heat to a different location where you can dissipate it with a larger surface area and quieter fans. So instead of cramming a small radiator setup into this new case where it'll get very limited airflow, I'll build a remote unit with much more capacity and the flexibility to hide my radiators out of sight. I'm playing around with a few ideas for this, and I'd like to make a dedicated video on it in the near future. The first problem I need to tackle is how I'm going to join my distro plates together at the corner. Water needs to flow between these panels, and I don't like the idea of using bent tubing with fittings. That'll take up too much room in a case of this size. Alex Banks, formerly the lead of the BitTech YouTube channel, has already found one solution, and he has a whole video about machining these brass blocks to achieve this. But I don't have a CNC mill or the ability to grow a mustache even close to this, so I'm going to have to come up with an alternative design that could be 3D printed. I have a new SLA resin printer on its way, but it won't arrive for another week, so I'm going to test a solution I thought of for my FDM printer first. I'm going to pour an internal silicone sleeve that's going to make sure the water stays isolated from the printed part. And in order to test this, I can use my existing distro plate assembly. I'll just have to make a couple small plates to give it something to mount to. I came up with the method for making these in my last video, and you should check it out if you want to see the full process getting here. These parts are made from TPU, which is a flexible filament, so it'll help seal the mold shut and prevent the silicone from leaking out during the pour. Last time I tried using TPU, the specific brand I was using was inhibiting the silicone from curing. But this time I switched to an 85 durometer TPU from Tech, and that seems to have solved the problem. They aren't sponsoring the video, and I'm sure there are plenty of other brands of TPU that would also work, but I still wanted to pass that info along in case it's helpful. I ran this in the loop for a good while without issue, and I'd feel pretty confident about putting this in an actual computer build. But now the resin printer is almost here, so let's make some room for it in the workshop. I had this slab left over from when I built the work table, and it's finally going to be put to use. Formlabs was kind enough to send us their Form 4 resin printer, and I'm really excited to add this capability to the shop. I've used their printers before in my day job as an engineer, and it can make prototypes that most would find hard to believe came from a 3D printer. They're definitely postured more towards businesses and professionals with their price point, but it's impressive how clean they've made the process of working with something as inherently messy as resin. Let me show you how it works by making another iteration of the Corner Distro plate mount. We can eliminate the internal silicone sleeve, and that demonstrates the first major benefit for resin printing: solid, watertight parts. It's still forming the part one layer at a time, but unlike the FDM printer, it's curing the entire layer all in one go as a solid cross-section. The resin in this tank is photosensitive, and underneath the machine has a light source that can precisely illuminate the areas it wants to cure into a solid. It starts out with the build plate about 50 microns above the bottom of the tank, which is also clear so the light can shine through, and it cures the first layer before lifting, mixing the resin, and repositioning the build plate for the next layer. Each time it's incrementing upwards by 50 microns or whatever layer height you choose, and repeating the process until it's pulled the entire part from the tank. Once it's finished printing, I'm going to move the whole build plate over to the form wash, and this is just an IPA bath that helps remove any uncured resin that may still be clinging to our finished part. And then we'll place it into the third and final unit, which is going to fully cure the part with more UV light and potentially some heat depending on the material. You just select the material and it has a pre-programmed recipe that decides time and temperature for the final cure. And then we can just break off the supports and we have our part. This design is just going to use some standard O-rings to help us seal against the distribution plates. What does a water cooling loop and your personal data have in common? Well, the last thing you want with either one is leak. So let me take a quick moment to tell you about today's sponsor, Incogni. If you're like me, you hate the idea of your personal data getting into the wrong hands, which can leave you exposed to things like scams and identity theft. And most times, this stuff gets out in leaks that are completely out of your control, like these large company data breaches that we hear about all too often. There's an entire online marketplace of bad actors waiting to take advantage of these situations, and this is where Incogni can help. You have the right to tell these companies to remove your private information. But there's one catch: you have to send a request to each one individually, or you could let Incogni step in and save you a massive amount of time. They'll manage all of the groundwork and keep you updated on their progress as they go. They even have a custom removal feature with the Unlimited and Family Unlimited plans that lets you point out a specific site you'd like your information deleted from. Privacy agent will step in on your behalf and take care of the rest. So go to incogni.com/visualthinker to get 60% off your purchase. Remember, use the code VisualThinker or just click the link in the description below to claim your 60% off today. Alright, let's get back to testing this part. I've always wanted to use resin for this application. The optical clarity is incredible, and there are just so many possibilities that you couldn't make with traditional manufacturing methods. Once the bubbles clear out of a cooling loop, it can be kind of hard to tell if the water is still moving, so I thought of another great use for resin. Let's see if we can make a flow indicator. I ended up spending a few more days running tests and looking for small ways I could improve my case design. Just some sanity checks and things that I wanted to try before committing to the full build. But I got all of the answers I needed, and I felt like I was finally ready to start printing the big stuff. This part is going to be for the front distro plate, and it incorporates 3 corner mounts as well as a flow indicator. I'm looking at this as the main stress test part for the resin. It has a lot of surface area touching water, so any issues with absorption or swelling are most likely to show up here. Since the real point of this case is to test water cooling, I'm just going to make stand-ins for the SFX power supply and the mini ITX motherboard. They're dimensionally accurate, so I can swap in the real thing if everything goes well. But I will be using a real CPU water block and a GPU left over from an old computer build. The distro plates look a lot cooler with some edge lighting, so I'm going to use some 5-volt LEDs around the perimeter. I'm making a little temporary fill point just so I can complete the loop without having the exterior radiator assembly finished. And now I'm ready to get started on the 3 other distro plates. I want to diffuse the LED light so I don't see the individual dots. This polycarbonate cladding should help, and it's just going to snap in over top of each strip. To help give the flow indicator some contrast, I'm going to print it using a different resin. And I figured this would be a good time to see the workflow for changing the machine over to a new material. The build plate goes into the wash for a quick clean while I swap out the wiper in the tank. You can use a separate set for each resin, and that way you won't have to worry about cleaning them every time you switch. I've had to do that in the past with other machines, and it's not a fun process. Plus you run the risk of accidentally mixing your resins. Then it's just reassembly of the build plate, and we're all set. This is when I realized I hadn't thought this through. I'm trying to fill the loop, but the air has no way to escape the system. I've just blocked its only way out with this little bit of water sitting in here, so I ended up getting rid of this stand-in for the external radiator, and instead I'm going to hook the case up to an external pump. There will be a pump and a radiator in the eventual external system anyway, and this is going to make it so much easier to fill the loop. It's been a couple weeks now since I finished the case, and it's been running continuously ever since with no issues yet. I'm just going to let it keep rolling, and I will follow up in the future if there are any updates. I wanted to create a lot of opportunities for failure with this case in order to really stress the viability of my designs, but there are some obvious things I would change if we were going to move towards a production design. The two side distros could be removed from the loop. They don't actually have a function besides looking cool, and the pump could be integrated into the front resin panel. That way I'd have easy access to the sides of the case without having to drain the loop. I also think I may have room to go even smaller. I'm going to have to start messing around with my cable management. I think that's going to be the next limitation on size, but this is not the end for this project. It's just the latest prototype, and I have a lot of ideas I'm excited to explore as this case design matures. If you want to stay up to date with this progress, I'll be posting updates for my Patreon members. I'd love to create a community over there where we can bounce ideas off one another, and you can stay more involved in the projects as I'm working on them. I already have a few ideas in the works, and I can't wait to share them with you. Thanks again for watching. See you next time.